Hey class, let's continue with this chapter 7.1 stuff. We're going to get into sort of manipulating identities and simplifying expressions. So one thing to practice is like number 8, start with a trig identity and write cosine in terms of sine. So if you just start with the basic one, you know that sine squared plus cosine squared is equal to 1. That relates sine and cosine right there. And now we just want to solve for cosine in this one. So we would express cosine in terms of sine. So if I want to solve for cosine, I would bring the sine squared over. So I'd have cosine squared equals 1 minus sine squared. And then I need to get rid of that square on the cosine, which is just square root both sides. So cosine theta. Anytime you square root both sides, you got to throw a plus minus. That rule from algebra. The whole thing, and then that's it. So there will be cosine expressed in terms of sine. So really it's all algebra. You're just doing algebra with trigonometric variables. Okay, so for the rest of these problems, we need to try to write the expression in terms of sine and cosine and simplify so that you have no quotients, so no fractions, and all functions are of x only. So no negative x is what that means. Okay, so what can we do with this one? Cosine, cosecant, tangent. So cosine, there's not much you can do with that. I will leave it cosine. Cosecant, I know by the reciprocal identity, is 1 over sine. And tangent is sine over cosine. Okay, and if it helps, then we can think of that cosine as cosine over 1. Now we're just, doing some algebra. We can remove sines and we can remove cosines because one's on top, one's on bottom. So that's going to just all equal 1. That's pretty simple. Okay. Let's try another one. How about this? Sine squared is cosecant squared minus 1. I've kind of zeroing in on this. Cosecant squared minus 1 feels like an alternate form of an identity. Let's go back up to when we did those alternate forms. Do we have a cosecant squared? There it is, right there. That's cotangent squared. Okay, so I can replace cosecant squared minus 1 with cotangent squared. Just do a substitution. So this is going to be sine squared times cosecant. All right, let's get that right. Cosecant squared. That's not even cosecant squared. Hey, have some more coffee. Cotangent squared. Right, by the identity. Okay, so that's good. And then now I got to replace cotangent squared. That's a quotient identity. So this is going to be sine squared times, see, cotangent is cosine over sine. Now algebraically, the sines cancel, the sine squareds cancel. And I'm just left with cosine squared. And that's in terms of sine cosine, just has x, and there's no fractions, so that's as simple as I can get. Okay, let's try number 11. That looks like a binomial times a binomial from algebra where you have to FOIL. So let's try that. I'm going to go 1 times 1, just 1. Then I'm going to do the outsides. 1 times cotangent. It's cotangent. The insides, negative tangent times 1, negative tangent. And then last, tangent times cotangent. Negative times positive would be a negative. And then tangent times cotangent. Okay, so that's first, outside, inside, last, FOIL, F-O-I-L. Now, I guess I can work with that last piece, tangent times cotangent. So these other 3, let's not mess with those for right now. That's going to be, I'm going to think of cotangent as 1 over tangent, because that's cool because then the tangents cancel. So now I've got 1 plus cotangent minus tangent minus 1. And then that plus 1 in the front and the minus 1 in back is 0. So those are gone. And so I'm just left with cotangent minus tangent. Now I could try to write those as sines over cosines, but then, I mean, what am I going to do with that? Am I going to combine them? Is that going to turn into anything? There's really nothing else we could do, so I'm just going to leave that as my final answer. Okay. Number 12. Oh, we got a negative in there. I'm going to have to deal with that. So let's go ahead and just do that right now. It's 1 minus. If I take that negative, I mean, I'm thinking about that, a negative identity. Sine negative x is negative sine x. Right? So that's going to be negative sine x squared. Okay. Remember that square where they put it, it's just a notation thing. It really just means the whole thing is being squared. And then, you know, if you square a negative here, it's just going to go away. So that top part is 1 minus sine squared. Okay, I'll put the square back to where they like to put it in these trig identities. Okay, and I still have that denominator, secant squared minus 1. Right. That should have been there too, but I didn't write it. When I clean this up, that'll be a secant squared minus 1 down there. Okay, now I have some alternative forms of Pythagorean identities. 1 minus sine squared is cosine squared. If you go back to that first page. Secant squared minus 1 is tangent squared. So I replace with my Pythagorean identities. And then now let's see. Tangent, sine over cosine. So we have cosine squared over sine squared over cosine squared. That's your denominator. All right. Okay, now flip that. I mean, like, you know, when you divide by a fraction, you multiply by the reciprocal. You know that rule from algebra? Okay, so we're gonna have cosine squared times the reciprocal will look like that. Okay. And then finally, all we can do is do cosine times cosine, cosine to the 4th over sine squared. Okay, now we do have a quotient here. It says don't write it as a quotient if possible. Is there any way around that? Well, I guess, I mean, that's not bad. I would probably just leave it like this. It's a little ambiguous on where you're stopping with these. That's why some of these will end up being multiple choice, so you don't have to figure out where to stop. But we could take this a step further and write it as cosine to the 4th times cosecant squared, right, without a fraction. Okay, so either one of those would be acceptable in my book. All right. How about one more or two more? Let's finish these off. We got more? Okay, that's it. Okay. How about sine minus cosecant? Okay, so sine is sine. Cosecant is 1 over sine. Let's think of that as sine over 1. So here's a scenario where you're going to have to subtract rational expressions. Algebra, ooh, got to get a common denominator, right? So over here, I'm going to multiply by sine over sine. Okay, for my common denominator. A lot of algebra in this section. So if you're a little rusty with your algebra, you're going to struggle through it a little bit more. If you're a little bit stronger with your algebra, it'll come a little quicker, but just stick with it. You'll be okay. Did I already say that? I don't know. Okay, but I said it again. All right. Combine these. So at the top, I have sine times sine, that's sine squared, and then minus 1, all over your common denominator, which is just sine x. Okay. And then sine squared minus 1, well, it's kind of like 1 minus sine squared, which is cosine squared, but it's reversed. So that's actually negative cosine squared over sine x. All right. And again, that's probably good enough because it's all in terms of sines and cosines, but there's some different forms. You could write that as negative cosine squared times cosecant x, right? Oh, there's some other options too, but that gives you a few, okay? So really here, you're just practicing, algebra and trig all combined. Okay, how about this last one? Looks like some foiling. So tangent times cotangent, anytime you multiply two trig identities that are reciprocals of one another, that's just going to equal 1. So you can just do that first step if you want. We saw that in a previous problem. Tangent times cotangent is 1. Tangent times cosine, let's just leave it that way. Secant times cotangent. And then secant times cosine. Okay, so now we've got, let's see, I would get everything in terms of sines and cosines to see if anything cancels. So tangent is sine over cosine times cosine. Secant is 1 over cosine. Cotangent is cosine over sine. Secant is 1 over cosine. And then you have cosine. Okay, now we should have some canceling. So let's see if we can get those cosines out. Those cosines, oh, a lot of cosines canceling here. All right, now we're left with 1 plus, that's just sine. That's 1 over sine. And that's minus 1. So the plus 1 in the front and the minus 1 in the back, those are gone. So I've got sine x plus, and then 1 over sine is cosecant x. And I'll leave it like that. Okay, so those will be similar to your homework. Use these as examples when you're practicing in that homework, and have fun with it. Let me know if you have any questions, and I'll see you in the next video.